Hello friends, now we are going to see what is meant by string efficiency in transmission lines. We know that string efficiency is very important for all technical exams. So let us discuss about it. Before going to study about string efficiency, we must aware about the potential distribution over a suspension insulator string. We know that suspension type insulator means that consists of a number of porcelain discs and which are connected in series through a metallic link. Here in this diagram you can see a 3-disc string insulator. Here 3 discs which are separated by a metal link or they are connected in series through this metallic link. Okay. And the point is that each porcelain disc which lies between this metallic link and this will create a capacitive effect because this metallic links or they are the conductors. Here the conductors are separated by an insulating medium or insulator that will forms a capacitive effect. So each disc will offers some capacitive effect because each discs which are separated by these conductors or these metal links, these two metal links which are separated by this insulator, hence a capacitive effect will offer here. So if here you can see 3 discs, that means here will be 3 capacitive effects that is shown here as CCC in this diagram. Okay, and here will be another capacitive effects present in this suspension insulator string, that is the capacitance between the earthed tower. Here you can see the earthed tower. So the capacitance between this earthed tower and the metal link, here that is represented as Kc. So here 3 metal links you can see. So there will be 3 shunt capacitance effects across this one, and here will be a shunt capacitance, and here will be another shunt capacitance. So for a suspension string insulator, there will be effects of 2 capacitance. One effect that is due to self-capacitance and another capacitive effects that is shunt capacitance that will occur due to the capacitive effects between the earthed tower and the metal link. Here it is represented as Kc. Okay. And V1 is the voltage across the first disc and V2 is the voltage across the second insulator and V3 is the capacitance across the third disc. Okay. If there were only self-capacitance, then the charging current distribution across each disc will be same. That means potential distribution or the voltage across each disc will be same. But it is not possible due to the presence of this shunt capacitance. So due to the presence of the shunt capacitance, charging current through each disc will not be same and hence potential distribution or voltage across each disc will not be same. So we need to calculate the potential distribution or voltage across each disc by using these formulas. But we know that the net voltage across the string will be the sum of V1, V2 and V3. But we have to find voltage distribution across the second disk, that is V2 is 1 plus K into V1 and V3 is 1 plus 3K plus K square into V1. We will get these equations by using Kirchhoff's current law at these junctions. I have written the final results here. So you will get V2 and V3 by using the KVL. Okay, KCL. So by rearranging these values, V is equal to V1 plus V2 plus V3, we will get V is equal to V1 into 3 plus 4K plus K square, where K is less than 1 and K is nothing but the ratio of shunt capacitance to the self capacitance. And it is very clear V3 will be greater than V2 and V2 will be greater than V1. We have seen that from the above discussion, voltage distribution across the whole disks which are not same. That means voltage distribution is not uniform. That means V3 greater than V2 greater than V1. That means voltage across the disk nearer to the conductor is maximum. Here we considered V3 is the voltage distribution across the disk which is nearer to the conductor. So that V3 is greater than V2 which is greater than V1. Okay, that means voltage across the disk nearer to the conductor will be maximum and the voltage distribution across the disk nearer to the cross-arm will be minimum. When we move from cross-arms to the nearer conductor, then what we can say? The disk nearer to the conductor possesses maximum voltage. Okay. This unequal distribution of the voltage is usually expressed in terms of string efficiency. Okay, so string efficiency is nothing but the that is the ratio of voltage across the whole string to the product of the number of disk to the voltage across the disk which is nearer to the conductor. That is V divided by N into Vn. Here V is the total voltage across the string of insulators, that is the sum of V1 plus V2 plus V3, or if there are n number of disks, then the sum of the voltage distribution across each disk, that will be capital V. So V is the total voltage across the string of insulators and Vn is nothing but the voltage across the disk which is nearer to the conductor and N is the number of disks. Okay. Now we can discuss about the methods to improve string efficiency. Okay. For that, first we can use longer cross-arms. We know that the string efficiency depends on the value of K. If the value of K is very less, that means string efficiency will be maximum. If the value of K is 0, then the string efficiency approaches to 0. So the value of K can be reduced by using longer cross-arms. We know that capacitance C is equal to epsilon A divided by D. That means if the distance increases, then the capacitive effects will decreases. If we use longer cross-arms, then the shunt capacitance effects will decreases and hence the charging current distribution across each disk that will increase and the potential distribution across each disk will be same and thereby the string efficiency will be maximum. So we can improve the string efficiency by using longer cross-arms and thereby the effects of shunt capacitance can be reduced. Second method that we can adopt to improve the string efficiency, that is grading of insulator disks. For equalizing the voltage distribution, the top unit of the string must possess minimum capacitance, while the disk nearer to the conductor must have maximum capacitance. If the capacitive effects increases, then voltage distribution will decreases. We know that in normal case, voltage distribution will be maximum to the disk which is nearer to the conductor. So if we use the disk having maximum capacitance nearer to the conductor, then we can reduce the effects of or reduce the voltage distribution. That means voltage distribution is inversely proportional to the capacitance. We know that voltage distribution is maximum across the disk nearer to the conductor, so that we can use the insulator which is having capacitive effects, maximum capacitive effects. But practically, this grading of insulator disk method, this method is practically which is not using. Third method, that is using guard rings. Guard rings are nothing but a metal ring which is electrically connected to the conductor surrounding the bottom unit of the string insulator. The guard rings introduces the capacitance between the metal link and the line conductor that will tends to reduce or cancel the shunt capacitive effects. When the shunt capacitance decreases, then string efficiency will improve. Okay, this is the main use of guard rings in transmission lines to improve the string efficiency by reducing the shunt capacitance. Okay, these are the main three methods that we can adopt to improve string efficiency in transmission lines. Thank you.